Hello to all class 10 students, our future scientists. Hope you're all good and healthy and studying too at home. So today I, Jasmine Kaur, I will be teaching you chapter 2nd of chemistry, that is acids, bases and salts. So the very big question that arises here is why we are studying this chapter. Do I need this knowledge anywhere in my life? The answer is big yes. We are totally surrounded with so many examples of acids, bases, and salts around us, and they have a vital importance in our life. Our day-to-day life, there are many examples which contains acids and bases. So coming forward towards a few examples, let us take citrus fruits. Citrus fruits such as lemon, orange. The reason behind of saying them citrus is they all contain citric acid. Another few examples of the substances which contain acids is vinegar. Vinegar also contains acetic acid in it. Soft drinks, which are almost favorite of every people, they also contain carbonic acids in them. Not only acids, there are many examples of bases also, just like baking soda and few medicines like antacids, soaps, they all are basic in nature. Not about acids and bases, there are few substances which are neutral in nature, just as water, sugar, common salt, and many more. So the question here is why we need them, why we need to study. So in this chapter, you'll be realizing the importance and the meaning of the word acid and bases. Moving forward, in the earlier classes, you were having the definition of acids. The acids are the substances which are sour in taste. So any substance which was sour in taste was called acids. Just like lemon, orange juice, they are containing citric acid, and that is also sour in taste. Vinegar also contains acetic acid and has sour taste. But the thing is, all the acids can't be tasted, so this is not the sole criteria to categorize an acid or base. Acids have a vital importance in our day-to-day life and even has biological importance. Just like in our body, we all are made up of proteins, and further proteins are made up of what? Amino acids, which are very important. Then HCl in our body, we all know that in our stomach HCl is being produced, which is a very important as it activates the enzyme pepsin, which helps in digestion of food. Even other examples like spinach, it also contains oxalic acid in it. Curd, which is made from milk, also contains lactic acid. Moving forward to bases, bases are bitter in taste and they are quite soapy in touch, so they are quite slippery. Just like examples are washing soda, baking soda, bleach, antacid tablets. But the thing is, we can't taste them. So never try to taste them and categorize them as acids and bases. Now the very important question, can there be substances which are neither basic nor acidic? The answer is yes. And they are what? Neutral substances. And we'll be learning about them in the further topics. Now further moving forward, in this chapter, there are various topics will be covered, starting with what are acids and bases, what are their properties, both physical properties, chemical properties, strength of acids and bases, how to identify what substance is an acid or a base, that is indicators, pH and its importance, and very important reaction of this chapter, neutralization reaction, then salts, how are salts made, what are the different types of salts, and we'll be discussing about some important types of salts. So starting with the very first important topic, what is an acids? So simple definition, any substance that produces hydrogen ions as only positive ion when dissolved in water. So in this, any substance which will be producing H positive ions or hydrogen ions or protons, they will be called acids, but it will only be produced when they are dissolved in water. So pure acids, They are usually in the form of simple covalent molecules. So all the pure acids, they are present as such as covalent molecules, and they do not behave as an acid unless water is present. So water is required for its acidic nature, because in the presence of water, acid will ionize or it will dissociate into ions. Otherwise it will not dissociate. So the question is, what is ionization and dissociation? It is a process of acid molecules forming ions in a solution. So simply, in simple terms, ionization is what? It is just acid molecules forming ions in a solution. So for any acid, we require a solution. Only in solution it will dissociate into ions. And acids are simply what? They are H positive donor, or they are called proton donors. And acids are very corrosive in nature. They can corrode anything. Moving further, physical properties of acid. As already discussed, they are sour in taste, but the very important property which we all know is they turn blue litmus to red. For example, take any acid in a test tube and use a blue litmus in it, it will always turn to red, indicating it is an acid. The next point, pH is less than 7. About pH we'll be learning in the further videos. So pH is just to categorize it is acid or it is a base, and for acids pH is always less than 7. Next, we know that electricity is produced due to conduction of ions. So as we all know, acids, they ionize into ions in a solution, so they also conduct electricity. Now moving further, types of acids. Acids are categorized under two categories: organic acids and inorganic acids, which are also called mineral acids. Organic acids are usually weaker and inorganic are usually stronger acids. Being weaker, they are less corrosive, but inorganic ones are more corrosive. So next, organic acids, they have a biological origin. Biological origin means they are mostly found in fruits or living tissues, but inorganic, they do not have any biological origin. They are mostly man-made or synthetic, and they are made from minerals. As we all know, organic term is related with carbon, so they all contains carbon atoms, but inorganic, they do not contain carbon atoms. Next example, organic, we have ethanoic acid, we have citric acid, tartaric acid, which is present in tamarind. Tamarind is imli. And among inorganic, we have various sulfuric acid, hydrochloric acid, and nitric acid. So moving forward, strength of acids. By the strength we mean either it is a strong acid or a weak acid. So strong acid is the one which fully dissociates. Fully dissociate means it completely dissociates into H positive and negative ions when dissolved in water. Giving example of HCl. HCl in a solution form or aqueous form, which gives you H positive and Cl negative ions. So weak acid is the one that partially dissociates. Partially dissociate means it will not completely dissociate, but partially dissociate to give you few H positive ions. So giving example, we have acetic acid, which partially dissociates to give you acetate ions and few H positive ions. So next we have basicity. This is quite an extra topic at this level. So what is basicity? Basicity is, it is a maximum number of hydrogen ions which is produced by a molecule of acid in aqueous solution. In simple terms, how much number of hydrogen ions will be produced by a molecule of acid. So on the basis of this, it can produce 1, 2, 3. If it is providing you 1 ion per molecule of acid, it is called monobasic. If it is providing you 2 hydrogen ions per molecule of acid, it is called dibasic. and if it provides 3 hydrogen ions per molecule of acid, it is called tribasic. So coming to the example, for example HCl. HCl will dissociate to give you H positive ion and Cl negative ion. So it is giving you single H positive ion. So it is monobasic in nature. Moving forward to diabasic, sulfuric acid. Sulfuric acid, when dissociates or ionize, it gives you 2 H positive ions and sulfate ion. As it is giving 2 H positive ions, so it is diabasic in nature, or its basicity is 2. Coming forward to tribasic, we have phosphoric acid. So it is giving 3 H positive ions. So it is tribasic in nature. So next we have base. Just like acids, they dissociate to give you H positive ions. So bases are the substances which produces hydroxide ions, that is OH negative ions, when dissolved in water. Another definition could be any substance that accepts H positive ions. So as we know, acids were called the proton donor, bases are called proton acceptor or H positive ions acceptor. So one word you must have listened, alkali. What are alkali? They are those bases which are soluble in water. All bases are not soluble in water. Only the bases which are soluble in water, they are called alkali. Then physical properties of base, we have already discussed. They are slippery in taste. They are bitter in taste. They are slippery in touch, and pH is more than 7. So they are having pH more than 7 and less than pHs of acids. And then next we have, it turns red litmus to blue. So if I am having any base in a test tube and I am using red litmus paper, it will turn always blue. Next we have strength of base. Just as in case of acids we have discussed, same is the case of bases. Strong base means which will completely dissociate to give you more OH negative ions, and a weak base which will show partial dissociation to give you less number of OH negative ions. So having example of a strong base, we have sodium hydroxide, potassium hydroxide, and among partial dissociation, that is weak bases, we have ammonia. Now moving forward to our next topic, concentrated and dilute. What does this term mean? You must have moved to your labs and bottles must be lying there, written on them concentrated acids and dilute acids. Now what is the meaning of those terms? Concentrated means there is large amount of an acid or a base in a given set of volume. So what is concentrated means? There is large amount of acid or a base in it as compared to given set of volume of water. And what does dilute means? There is small amount of an acid or base in a set volume of water. So it means in dilute water will be more, and in concentrated there will be large amount of acid or base. Now the very big question arises, how I can know that what substance is an acid and what is a base? So for this we have indicators. From the word indicators, it means it should indicate something. So what is an indicator? It indicates whether a substance is an acid or base. In actual, there are various kind of indicators. So we have natural indicators and synthetic indicators. Natural are the one which are obtained from natural things, and synthetic, they are all man-made. So we have litmus among the natural indicators, litmus, turmeric, that is haldi, and red cabbage leaf extract. So what is the thing is, in synthetic we have phenolphthalein and methyl orange. Now the question arises, how they indicate? So they indicate by the change in color. The color is different in acids and different in base. So litmus, it gives you red color in acid, and blue color in base. In turmeric, there is no change in acid and red color in base. Red cabbage leaf extract, it gives you red color in acid and a green color in base. Moving forward to synthetic indicators, phenolphthalein, it is colorless in acids and pink color in base. Methyl orange, it gives you red color in acids and yellow color in base. This is a very important CBSE question, the color changes. So I repeat, phenolphthalein gives colorless and pink color in base, and methyl orange, it gives you red color in acids and yellow color in base. Now a new type of indicators is olfactory indicators. They indicate through the change of smell. They indicate whether the substance is acid or a base with the help of smell. So, for example, onion. It gives a characteristic smell in case of acids, but it gives no smell in case of base. So, there are various other examples, just as clove oil, vanilla extract. They all come under olfactory indicators. There are other examples also of another kind of indicators, universal indicator. We can use also pH. Universal indicator is actually a mixture of various kinds of indicators. So moving forward, next topic is pH. So now the question is, what does the word pH means and what it is used for? So pH actually means potential of hydrogen. Here P detects potence, which means potential, and H determines hydronium ion concentration, that is H3 or positive ion concentration, and its formula is written as pH is minus logarithm of H3O ion concentration. So we can easily define pH as negative logarithm of hydronium ion concentration. Now what does this pH do? pH is just used to determine the strength of acid or a base. Means if the acid is strong or is it a weak acid, how we can know that? So we can just use a pH paper. pH paper is just like the litmus paper, and we can use it and we can compare the strength of an acid and base using a pH scale. Now what is pH scale? pH scale is also used to measure the concentration of hydrogen ion in a solution. So we are having a pH scale ranging from 0 to 14, which helps to determine the strength of an acid or base. Means, for a simple example, if I want to know that my acid is a strong acid or a weak acid, so I can simply use a pH paper and a pH scale to know the strength of my acid. So what is pH scale? We are having a 0 to 14 scale. This is 0 to 14. On the left side, more acidic. On the right side, more basic. And 7 is always neutral. So if I am moving towards left, acidic character is increasing. If I am moving towards right, basic character is increasing. And what happen is, more acidic means more H positive ion, more basic means more OH negative ions. So if I am moving from left to right, OH negative ion concentration is increasing and H positive concentration is decreasing. And if I am moving from right to left, there is H positive ion concentration is increasing and OH negative concentration is decreasing. So what it means is, 0, it is strong acid, 0 to 2, then 3 to 5, weak acid, 7 is neutral, this is weak alkali or a base, and this is strong alkali. So this range is strong acid, weak acid, 7 is neutral, then weak alkali and strong alkali. So we got the answer. Acids have pH less than 7, means less than 7 they are acids, and more than 7 they are bases. So now the thing is, lower pH, more stronger is acid. So pH is lower, that acid will be more strong. Similarly, more is the pH, stronger is the base. Means if pH is 14 and 13, which will be a stronger base with the pH 14. So, next example in our daily life of pH coming forward at 0 pH. At 0 pH, we have very strong acid, hydrofluoric acid, which is HF. Then 1 HCl. Then at pH 2, we have lemon juice. Then at pH 3, we have soda, orange juice. Then at pH 4, tomato juice and acid rain. So rain is called acidic because of the acids present in it, and it can destroy the plants. So at pH 5, we have black coffee, urine and saliva. They have pH in the range 6 to 7. And pure water only has pH 7, that is, it is neutral. Next, seawater is saline in nature, so it comes under pH 8. Baking soda, pH 9. Milk of magnesia, it is magnesium hydroxide, so it is at pH 10. Ammonia solution is at pH 11. Then soapy water, pH 12, and bleach at pH 13, and pH 14 is liquid drain cleaner. So what we understand is more is the pH, that is the strong base, and lesser is the pH, that will be a strong acid. So let me ask you a simple question here. So for example, if I have more H positive concentration, is it a strong acid or a weak acid? So answer will be it is a strong acid. So more is H positive concentration, it will be a strong acid. And if I have less H positive concentration, it will be weak acid. Clear with this concept? So moving forward, we have chemical properties of acids and bases. Chemical properties means the reaction with metals, carbonates, reaction with bases, and etc. So starting with metals. What happens when acids react with metals? So keep this in mind. Whenever an acid reacts with metal, it always gives rise to salt and hydrogen gas. Taking a simple example, acid we are taking HCl, dilute HCl, and metal sodium. Whenever sodium will react with HCl, it will give rise to NaCl and hydrogen gas. For detecting hydrogen gas, there is a simple test which is called pop sound experiment. What you have to do is, when we are performing this reaction in a test tube, take a burning splinter near the mouth of the test tube, and you will experience or you will hear a pop sound. From that pop sound, we can determine that hydrogen gas is being produced. So whenever any metal reacts with acid, hydrogen gas is being produced. Next reaction with metal carbonates or bicarbonates, or we can also say hydrogen carbonates. Next, so whenever any acid reacts with bicarbonates or carbonates, it gives you salt, water, and carbon dioxide. So taking example, I am taking calcium carbonate as metal carbonate and acid as HCl. So what is happening? It will give you salt plus water, and carbon dioxide gas will be released. So now the question arises, how I can test that carbon dioxide is being released or not? So there is one test. Whenever carbon dioxide is passed through lime water will turn milky. Why it turns milky? It is due to the production of white precipitates of calcium carbonate. So here is the reaction. We have lime water, that is calcium hydroxide. Whenever carbon dioxide is passed through it, it will gives you calcium carbonate, that is limestone, which is having white precipitates and which will cause us milkiness. But if I pass excess carbon dioxide, it will result in formation of calcium hydrogen carbonate, which is transparent in nature, and then there will be no milkiness left. So this is an important CBSE question, that why white precipitate goes away or why it becomes transparent. So next we have reaction with metal oxides. So what are metal oxides? Whenever any metal reacts with oxygen, it gives rise to metal oxide. So now metal oxides, as we know, they are basic in nature. Metal oxides are always basic in nature. So base, it will react with acid and it will always give you salt plus water. Taking a simple example, copper oxide. So copper oxide, when reacts with acid, it gives you salt plus water. Next is reaction of acid with the base, that is neutralization reaction. Acid plus base will give you salt plus water. We'll be studying in the later topics. Next is chemical properties of bases. Same is the case with acids and bases. Reaction with metals. Metal will react with base to produce salt plus hydrogen gas. Same, zinc treated with base NaOH will give you sodium zincate with the release of hydrogen gas. Now next, reaction with non-metallic oxides. Just as metal oxides, they are basic in nature, non-metallic oxides, they are acidic in nature. So if they are acidic in nature, they will react with base to give you salt plus water. Taking example of non-metal oxide as carbon dioxide, treat it with calcium hydroxide, it will give you salt plus water. So next we are having what happens to acid and base in water. That is, whenever if I am adding any acid or any base in water, what happens to it? So it's quite simple. In the presence of water, we have already studied that acids or bases, they ionize in water, means they dissociate to gives you ions. So in presence of water, acids will gives you which ions? H positive ions. But those H positive ions, they cannot exist alone. So what they do is they react with another molecule of water. So this is acid, treating it with water, it will give me H positive ions and that negative part anion. So what will this H positive do? It will react with the water molecule and it will gives you hydronium ion, that is H3O positive. And in case of bases, what happen? They dissociate to give you hydroxide ions. So in short, what happens to acid and bases in water? They dissociate into ions. So water is very essential for the dissociation of acid or a base. If water is not present, they will not dissociate. So here a very important question is, why HCl gas do not conduct electricity? The answer is simple, because it will not dissociate into ions. So next, what is the word dilution means? So dilution is now simple. It is mixing of acid or base with water. Means just adding water or mixing water with the acid or base. So now what happens? What is the effect of dilution? It will result in decrease of concentration of H positive or OH negative ions per unit volume. For example, if I am having any acid, it is completely dissociated, giving me more H positive ions. But if I am adding water in it, the number of H positive ions will obviously decrease per unit volume. Now, the very big question, how do acids and base react with each other? So, acid plus base react to gives you what? So that will be covered in our next video. Thank you.